September the 6th, 2016. Notice your timestamp in the bottom of these LASCO C3 Earth-facing images of the Sun. Today we had what was called a prominence release. Now, this thing started on the 3rd, and you saw the comet come in. Again, notice your timestamp coming into the 5th. That's the video I did last night of the filament release. Now, going into the 6th, it was called a prominence release, and that was the technical name for it. Very large compared to what we're looking at here. Same satellite, different camera. This is LASCO C2. Notice your timestamp on the 4th. In the 5th, again, the filament release, when we started watching for the earthquakes. They have, they came in, they impacted hard, and they're continuing. Notice you're at 1400. This is UTC time. Take out about 5 hours, and you're close to East Coast time on the 5th. You've got the, again, the filament release, but today, on the 6th, this is very explosive. A large amount of the surface of the Sun exploded in what was called a prominence release. Check that out. Notice your timestamp. It continues with that outflow for several hours. What happens is that expands outward. Again, on the 3rd, you see the comet coming in. Now, when you're dealing with an explosion of that size, it expands outward. It doesn't expand on the back side of the Sun, but if you see that explosion, it has an effect on our planet. And the best way to tell that is to go, again, on our website, we have all these links. You're looking SDO, LASCO, but go and look at your ACE satellite images. Notice your timestamp, the 4th. First release, the 5th, another release. But that main filament, guys, that we're watching that's now crossing to the right center of the Sun is still intact. But it's about to cross the Sun's and Earth's magnetic connectivity point. And I've seen a large amount of growth in that particular Earth-facing filament. Notice your timestamp again on the 5th, coming into the 6th. Check this out, guys. Remember, it would take 109 circles the size of the Earth to cover that white circle that we call the Sun. Check that explosion out. Let's go to the satellite on the back side of the Sun. You'll see the explosion from the opposite side. This is stereo head, COR2 images. Watch this. Very impressive. Notice your timestamp on the 6th. This thing happened starting at around the 10th hour universal time. Guys, that's amazing. Again, look at the size of the Sun compared to that explosion. Look at the size of the filament now. At least 30% growth in the last 48 hours. It is now past the point where we were looking at the Mars and Venus connection point. You see this? Excuse me, Mars and Mercury. But the Earth connection point is that blue dot right there. That magnetic connectivity point has a lot to do with the release of both intense solar flares and these filament releases. Check it out as we go through the SDO images. But also we talked about CERN. When you talk about CERN and you talk about the Earth-Sun's magnetic connectivity point and CERN's magnetic field that's 100,000 times more powerful than our planet, you're dealing with problematic issues. Also, notice the filament release that we recorded is that explosion coming back right there. That's what we saw release from the LASCO C3, the C2 images, and the stereo A images here on the back side of the Sun. It's amazing that we're finally getting ahead images because they were gone for almost a year. Both satellites were on the back side of the Sun. We may never recover stereo B, but the optics had been damaged by X flare a few years ago. Notice your timestamp. By 1100 hours, we were seeing these pulses come through. That's the early warning system for our planet. But you have two things that occur. You have the initial flash, which can take 8.2 minutes of light energy or proton energy to travel from the Sun to the Earth, and then 24 to 48 hours of an outreaching coronal mass ejection. Many people will say, well, that was a blast off to the right. You saw the expansion from the surface of the sun. It does it in all directions. We're going to watch that. Another interesting thing is today, we've had strong earthquakes, 5s, and after that point, and you notice your 1,500 hours, that was 4 to 5 hours after the initial flash. Something very interesting to me. In Tennessee and Alabama, two of the smallest quakes on the entire map may possibly have the largest implications for this section of the planet. Here today, just southeast of Knoxville, Tennessee, we had just a 2.5. But yesterday, we had a 2.6 in Aliceville, Alabama. What do they have in common? The greatest geological feature in the southern United States is this thumbprint. Many have, this is an indentation that happened from an earthquake a long time ago, and it had a lot to do with the New Madrid fault. Then the new one that's just southeast of Knoxville has to do with the Appalachian chain, which has everything to do with what's called the North American craton. It's a large rock. It's millions of years old. But the one there in Alabama, guys, when you think about, and if you've never seen the Navy maps of what would happen if we had another New Madrid experience, all of that land in that area is underwater. Also, many retiring people in the military are getting above the 400-foot level and buying land in northern Arkansas above that particular flood zone. So they know something that they're not talking about, but remember again the naval map showing how all of that area was flooded. There's a lot going on, and we're watching it, guys. Pay attention to the storms in the Atlantic, and you guys on the East Coast. Remember, I've been talking about for a few days that Long Island, New York would be sitting there getting battered by wind and waves for several days. We're already seeing